we need to talk about idealized scenarios. In some problems, we need to simplify the problem so we can solve it. And the assumptions that we make are usually good enough for a good answer. Okay, for example, in physics class, maybe you assume that there was no air resistance. And for a lot of problems, that's a good assumption, which makes the calculations much easier and you still get a fairly accurate answer. In this class, we'll be doing the same thing. So let's talk about our kind of first object our idealized object is called a particle. And this particle, we assume has a mass. So it has a mass, but no size. So it doesn't have a size. So, for example, if we were analyzing a problem that was a bullet, maybe the particle is a good idea for that. Okay, so for the next one, a lot of these bodies, when we apply forces to them, such as this pencil, we'll see it bend a little bit, right? But it doesn't bend a whole lot. And so if we want to talk about things bending, we would usually have to take a class in deformable bodies, right, where objects are bending. In this class, this introductory class, we will be primarily talking about objects that do not bend, or bend so little that we can assume that they don't bend at all. And that sort of analysis, that sort of object, is called a rigid body. So a rigid body. Okay, so it has mass, it has size and shape, but does not deform. Okay, so we have the particle, we have the rigid body. Now let's talk about as we apply forces. For example, let's say we have a car tire, right? Some sort of car tire here, and it's resting on the ground. Let's see if I can draw the ground here. Okay. We know that this car tire is going to deform a little bit because it has the car's weight on top of it. And the weight here, right, as it pushes down, is going to create a normal force, or a force back against the tire wherever it's touching the ground. Okay? All right, so this is kind of the real scenario. But in this class, right, we assume that the car tire is rigid, all right, and the force, we add up all these tiny forces that are distributed along where this tire is touching the ground, and we add those up to a single force F there as the sum of all these forces. And those are just a few of the idealized situations, this one being called a concentrated force. Concentrated force.